Hi folks, welcome to the Break Team. My name's Henry, and today I'd like to say happy SepTandy. SepTandy, we celebrate all things Tandy, and this month, this SepTandy, I am celebrating by working on some real hardware today, actually inside the Coco. What we're going to work on today is a ROM adapter for the Coco 1. Now, we've seen these things before where you've got a single 24-pin ROM that you adapt out and make a 28-pin ROM fit. Well, since 24-pin ROMs, or since 24-pin EEPROMs, I should say, are kind of unobtainium these days, but 28-pin EEPROMs are still quite readily available. And since I can get a 28-pin EEPROM that is 16K in size and will accept both the extended the extended ROM and the regular ROM, well, why not just go ahead and kill the two birds with one stone? In the Coco 1, they're right beside each other, and it looks like it should be a simple enough thing to build the adapter. It's just some wiring and maybe some select logic and things of that nature. I mean, come on, how hard could it possibly be? He says foreshadowingly. At any rate, let's go ahead and see about what this looks like, how we're going to get it put together, and get some practice in, because there are some other projects that I have in mind that this is kind of practice for as far as routing things around and figuring out what's going on the innards of this machine. So sit back, relax, and let's have some fun. So the first thing I want to make sure of is that I know what's doing what as far as enabling things. Now on the 364, it looks like we've got an enable pin over here that'll drive low. That'll drive low to the enable pin, so it's not going to start spitting stuff out on the data bus until it gets the appropriate signals. These are coming from Yankee 1 and Yankee 2. It looks like Yankee 2 is follow you. Let's do this. Looks like Yankee 2. We come along here, come up here, and Yankee 2 is activating. That is U3, which is the standard ROM, and Yankee 1 is activating the expansion ROM. All right, so here. All right, so for the SAM, we'll come back over here and redo this. For the SAM, that's Yankee 1 and Yankee 2, which that's going to be S0, 1, and 2, the device selects. And I want to look at the memory map for that, which is going to be... Where's my memory map? There we go. We're going to be in map type 0. And that map type, S is equal to 1 for ROM 0, S is equal to 2 for ROM 1. ROM 0 is going to be the basic ROM, ROM 1 is going to be the expansion ROM. Let me verify that over here. S is equal to 1, which gives me Yankee 1 activates that. Is that correct? The expansion ROM? 8,000 to 8,000. And that is correct. Okay. Because this is the expansion space from 8,000 to 8,000. And then from 8,000 to BFFF is going to be the standard basic ROM, which is going to be signal 2, which means that when I'm interfacing from this one, what I should see is I'm not sure. You know what? Let's look at this on the schematic and make sure that I know what's going on. All right. So here we are with, I want to look at what's coming off the, where is it? This is, okay, here we go. There's 67331. I don't think that's it. No, that's one of the Pias. Where'd the SAM go? I think you're the SAM, aren't you? No, you're the 6821. You're the 6847. Here we go. You're the SAM. All right, S0S1, and you're coming over here. So what I'm looking for are Y1 and Y2. And so that gives me, okay, so that's simply an OR gate. Or no, that's a NOR gate. This is a NOR, this is a NOR. So when this is selected, Y1 is selected, what's my other input here? And then let's look at where this is going. This is coming out here, coming down here. Okay, I see what we're doing with that one. And that's going to be jumper 5. So if it's coming over to the 128K jumper on jumper 5, that's coming to chip enable. All right, so from this one, we already knew that we were looking at a low-going signal enables the chip. So this actually does the chip enable. All right, what gives me output enable? And output enable is jumper to ground when you're at 128K. All right. How do we look at, I want to see what's giving me, A12 should just go straight to A12 from the, now, in the case of A13, you simply run to A13. Now, okay, right, because what we've got, okay, now, but the next trick is, does that even really matter? All right, so let me look back again over here. Y2, and gives me that. So if either of these are on, I see why they did it that way, because they needed, okay, those are inverted. So if these, let's see, that's tied to ground. So if this is high, this is conducting. All right, hang on a tick. Let me look at the logic here again. Y1 and Y2 are necessary for chip select and for enabling the outputs. We only want to look at the ROM space if Y1 and Y2 are low, in which case, given the 128K for decoding, that's what we're doing. Now, and that's what they're flying onto. They're going to chip enable and the output enable. Let's see. Now, what was I doing with the output enable was simply tied to ground. Output enable is always high, or is always active. Chip enable is the one that's going to be triggered over here. So they're just leaving that like that. And then the rest of them just tied to the address bus. Now the trick is, I don't have A13 available from the address bus, but I should be able to synthesize something similar. Because if Y1 is active, that means, no, that's not correct. Let me look at that again. Let me make sure that I'm looking at the correct thing. If Y1 is active, that means that I am looking at the ROM expansion, which is the lower bits of that, which means that A13 is actually going to be, is this my A13 signal? No, I need that. Okay, if that's going to be my chip enable, Y1 and Y2. Why am I doing this? Because I don't want to have to deal with taking a runner and going from blah, 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 blah. Okay. Y1, signal 1, ROM expansion. When this is low, A13 will be low. When this is high, A13, so I can use this as my A13 signal directly. I can effectively use this as my A13 signal. All right, so that's what that looks like we're doing. Let's see if I can't get something started in KiCad here. That's old. There we go. You have to switch to select a library before you can create a symbol edit. But if you select a library, symbol editor view show symbol tree is on by default. Oh, okay. So I actually need to go into the symbol editor. Now, the other thing that I just realized is I need to fix this because these are supposed to, this is actually the pin header. So that's actually going to, everything there's going to reverse. So the address lines And then the next thing that I want is I want to add a symbol, and I want it to be, let's look for the 27C 128. I have it. Nice. Okay, so it's obsolete, but that's fine because this is what I'm going to be using. All right, time to put together a truth table. All right, so E0 and I want to look at which those are going to be the same, so it doesn't matter. All right, if that is going to be, if both of these are 1, I want this to be 1. If either of these are there, I want that to be a chip enable to be a 0. I want that to be a 0. And in this case, the 0, 0, they should not both be enabled simultaneously. But in either case, that's, so what I've got there is effectively, that's an AND gate, my friends. So that's a very simple thing to put together. It is. Oh, that's right. Okay, never mind. Never mind. The upper bits don't matter because we're using the enable pin from the SAM. Because of the way the enable pin works on the SAM and because those are not going to be enabled, unless the SAM is enabling them, we're not going to actually have the upper bits matter. I don't have to decode those. The SAM is already doing that for me. Now that makes a heck of a lot more sense. Okay. And since the SAM's already doing that for me, I've got this right here. This is going to be my lower bunch. It's going to be my upper bunch. That's going to go directly in also to A13. That's effectively becomes A13. Not a problem. That should work. Okay, so now that that's taken care of, let's see about a PC board for this. design rules checker and run the DRC. All right, looks like everything's fine. All right, so the next step with this is going to be to send it out to be fabbed. It looks an absolute mess. This may or may not work. We'll find out, though. And back from the fab now, we've got the nice little JLC PCB, not sponsored yet. JLC PCB, let me know. And opening it up, of course, in our silica gel, we've got our PC boards, nice. This will make for a wonderful little possible shipping thing later. The way that I designed this, these are going to be headers. That's a socket, and that's a socket. Now, that's going to be 24 pins worth of headers. Beautiful. And I don't think it's going to make sense for me to stick those through. Yeah, that's going to be the direction I'm going to stick them in. So I need 48. Okay, this isn't going to be as bad as I thought it was going to be. Ow! That's hot, that's hot, that's hot. Okay, but that's tacked into position. And I'm specifically only using a 128K ROM. I'm not trying to use anything bigger than that just yet. That's going to be a little bit of a redesign to do that, and I'm not sure how I want to play that out. So yes, there is actually heat transfer that happens when I'm using my pinky to hold this underneath. So what I try to do is I try to keep, like, the finger that I'm using to support this underneath, I'm trying to keep that away from the pin that's being soldered. However, sometimes it gets there, and yes, you can burn yourself, so do take care. And, you know, I'm not adhering to all the possible safety precautions that I could be using, so just take safety precautions into account. That's all the soldering that needs to be done. And that should take care of that. I'm going to let that air dry for a minute. And there are the ROMs. Now, I do not have an appropriate chip puller, and I have not put deoxit into that. So I'm going to ever so gently
Let's go.
A chip puller would be nice. Yes, a chip puller would absolutely be nice. Now, if I've done this correctly, I've left myself with enough room. Yes, it's seated. Beautiful, it's seated. That's absolutely perfect. Okay, now, I need to check something again real quick. And you are a 74LS08. Now the next trick is going to be to actually get this thing done. So what I'm going to need to do is burn 128K ROM, and I'm going to need to burn that 128K ROM such that the upper half of it is the fourth side, the lower half of it is is empty at this point in time because I don't have anything to go there, which is perfectly fine. So right, let's look at that. So that's all good all the way down to, and I should about see as we go down to about 2,000, I should see something. There we go. There's all our nice little data. Got all sorts of extra space in there. This is a very, very sparse. Oh, right. Got it. That's what those are. Those are actually the vectors. Okay. So that's good. I should be able to just, let's Control Q that. This ROM is not empty. Okay. Thankfully, that's easy to fix. Because off to the side, I have a UV EEPROM eraser. Fresh out of the eraser, let's make sure that I've got this set up correctly. Bink. And if you ever want to play around with burning your own ROMs or burning your own EEPROMs or what have you, these things are relatively cheap. Okay, and the verification went fast. It took a full 35 seconds to write 16 kilobytes. That's nuts. It is what it is, I guess. Okay, great. So the ROM is burnt, verification went okay, and let me go ahead and do this into test.rom. I know it already did the verification. This is just to set my mind at ease. I got something, but I'm getting no response from the keyboard. Let's reset. Give me AHX0. Something's working. Well, folks, I honestly don't know exactly what's going on, and I don't have a good idea of how to trace this. It's so much easier to do the debugging on emulation. Theoretically, what I did should have worked, and it looks like it's trying to work. That's all I can say. It looks like it's trying to work. I just don't know what the code path is doing or whether I royally screwed something up. Whatever the case, there is one more test I can do. I just thought about that. Let me try this. I need to erase this EEPROM, and I need to get the ROM files for Color Basic and Extended Color Basic, load those up onto the EEPROM, and give it a shot. So let's go back to that and let's try that. All right, so while I'm waiting for that, let me go ahead and do some sanity and continuity checks real quick. Yep, everything checks out continuity-wise, so we're good there. And let's see what we get. And I get a good boot. All right, so excellent. That tells me that since this is working, okay. That board works. That board works. Well, that's a wonderful thing because that tells me that at least part of this SepTandy project, well, I don't know if let's call it a SepTandy project because it's SepTandy and it's fun. That this little bit of the SepTandy project of doing the adapter board works. I'm happy. The adapter board is actually working. I've got extended color basic booting. My Forth ROM, however, is a different story entirely. I'm not sure what's going on with that. Hi, folks. Welcome back to the Break Key. My name's Henry, and today I just couldn't get to sleep. That ROM thing where it wasn't working was really bugging me, and the fact that it worked in MAME and didn't work in XROAR was really bugging me, and the fact that it doesn't work in XROAR in general says that there's something decidedly wrong because XROAR is, well, so far it's been the one that if it works in XROAR, it's going to work on hardware, and if it doesn't work on XROAR, it's not going to work on hardware, or find the problems there. So I'm thinking that I might have an idea of what is happening with this. I took a gander at it. I think I've got an idea, but I need to make sure. So here's what I'm going to do. I'm going to set up XROAR because where I was seeing failures, I was not seeing failures in MAME, I was seeing failures in XROAR. I'm going to set up XROAR to test this. So I've been using MAME because MAME has some absolutely wonderful debugging capabilities. However, XROAR tends to act more like the real hardware more reliably than MAME does in certain circumstances. Kieran's really, really good about getting those edge cases going properly. Okay, so the first thing I want to do is set up an XROAR target in my makefile. Okay, and that's what I was seeing on the Coco on the real hardware. I was seeing something like that. So I've got a sneaking that when I look through this, I believe I'm missing a bit in my SAM wake up. Okay, so here's my SAM wake up. We have 3 bits in display mode control. I have each store as a bit, so that's 1, 2, 3 bits in store mode control. We have 0, 1, 2, 3, 4, 5, 6. So that's going to be 1, 2, 3, 4, 5, 6, 7. Okay, so I'll start with a 0 and see what it is. I think this is what happened. So 0, 1, 2, 3, 4, 5. I don't have the 6th bit. Now that one is going to be a 0. So I should be able to fix that. Now the next thing is page number 1, okay, which is there. That's 1 bit, and that's supposed to be equal to a 0, which it is. The next 2 CPU rates are going to be zeros, which they are. And the memory size, that looks like it's going to be a 01, which is what I want because we're going with the 3264K, at least for right now. And the Coco that I'm running it in is going to be a 3264, is a 32K machine. And then map type set to 0 by definition. Now that is initialized. Something else I noticed that I think is going to be a problem, or I think it's part of the problem, and I'm really kind of kicking myself about it. The SAM is what controls all the memory. Like, if you don't have the SAM appropriately set up, you never know where it's going to try to write things when it tries to write things. You know, for all I know, it's got a different page selected or something like that. Don't know what's happening with it. So I'm setting up all these variables, the initializing of the variable area and setting up all these things well before, you know, error vector table and everything, well before I even set the SAM up. So I've got a sneaking that if I take this and actually like make it the first thing we do aside from fiddling with registers and setting up constants, because all these are constant locations. This is not defining any data in memory, it's just defining locations. These are all constants. That's okay. That's constant information that's already in ROM. Let's see. Yeah, that's already in ROM because I've already set the org at 8,000 there. That's an equate, that's an equate, that's an equate, and those are the FCBs. That's already set up. The first time it actually tries to look at RAM is when it's setting up the error vector table. So if I put that over here instead of where it was, let's see what winds up happening. That should take care of everything when I run it. And would you look at that? Who'da thunk it? You want to set up the memory manager before you start using the memory. Who'da thunk that would have been a good idea? Yeah. Okay. And just to be sure that everything's working. Yep, we're fine. Everything is perfectly fine. It's working. It's doing what it's supposed to be doing. All right, so I'm going to take a cut here real quick and just do the burn, load it up, and let's see what it looks like on the actual Coco. Yep. Should have everything nice and set up so that when I turn this on, let me turn that off because that'll be distracting. All right, so oh, that makes me happy, that makes me happy, that makes me happy, that makes me happy, that makes me happy. Okay, I'm gonna get this on. Yes. Yes, look at that right there. It is running on real hardware. It's working. Oh my goodness gracious me. It is working. That makes me so flippin' happy. Oh yeah. Woohoo! Yes! Oh, that was annoying. Oh my goodness. I cannot believe that I didn't think about the fact that not setting up the memory manager first thing would cause me problems with being able to appropriately access memory. Who'd have thunk it? And I can understand that I didn't use XROAR because, well, they all work the same, don't they? Apparently not. Apparently, XROAR actually gives me the random-ish stuff that MAME does not. Wonderful, or at least the random startup state for the SAM that MAME does not, and that's great. And lovely, lovely. Even if I hadn't had that success, as we saw in the last attempt at an outro, I've got a functioning ROM adapter, and I can go ahead and get it's a real simple thing to just modify that and modify that. So maybe instead of a 128K, I've got a 256K in there, set a dip switch so that I can select between the Forth ROM and the extended color basic ROM. I'm just happy. I'm just so happy. It's working. I can actually show this now. This is wonderful. And yeah, I'm planning on showing this at the next New England Classic Gaming meetup, which is going to be in November. And I'm definitely bringing this ROM along with the real hardware it's running on to Cocoa Fest in May. Thanks so much for being here with me. Hope you enjoyed the process. Like, share, subscribe. Y'all have a great night. I'm going to get some sleep.